in these days with having to do these workshops virtually over the internet. Typically, our maintenance, troubleshooting, and repair class covers all three types of irrigation systems: drip irrigation, bubbler irrigation, sprinkler irrigation, troubleshooting, and then all sorts of repair things. Now, when we do these classes in person and all together, that's a 3-hour class. So we know people aren't going to be willing to sit through a 3-hour video class. So that's why we've broken them up. And tonight's class is specifically on bubblers and sprinklers, irrigation system basics. So this is all going to be about maintenance, how to take care of your system when things go wrong, how to troubleshoot what the problem is, and then some really good repair techniques that'll help you out when things do go wrong. And the arrow keys are no longer working again, so we'll use the mouse wheel. So we do need to remember that these automatic irrigation systems are mechanical. It's piping, it's valves, it's wires, all that sort of thing. So that means, just like cars, we need to do the maintenance on them. So you need to change the oil on your car every so many miles, depending on the oil that you're using. And you may decide to save yourself a little money and not get your oil changed. But if you take it too far, you're going to find out just exactly how much it costs to replace the engine on that car. And that's the thing about maintenance. It's going to be taking care of most of your problems before they become big problems. Or if you're keeping up on this as a regular basis, hopefully you're going to catch these things before all of a sudden you get that very large, shocking water bill. So I hate to tell people this, but installation is only the beginning. And that's the downfall of a lot of our irrigation systems out there. People don't pay attention to them until things break. So without maintenance, plant health can suffer, sometimes to death, if you're watering your shrubs and trees with bubblers. Your grass can go into stress if you're having problems out there. The system can deteriorate to the point where replacement is your only option. So it'll just get so bad and all the components will begin to fail one after another. And pretty soon it's actually more cost effective just to abandon it and install a brand new system. With a good maintenance regimen though, there's no reason not to have a 30-plus-year-old irrigation system in the ground. There's lots of them all over the place. And of course, very important to us all here in our desert is water can be wasted. The most efficient a typical irrigation system will be is the day that it's installed. Over the course of time, with lack of maintenance and poor management, a lot of water ends up getting wasted. So by making sure you're doing your proper maintenance and doing it properly with the proper replacement components, you're going to make sure you maintain the efficiency of the system. The more efficient it is, the less water you have to use to still keep your beautiful and healthy and happy yard. So there are different types of irrigation systems out there. I, like many people, came to Arizona from somewhere else. I grew up in northeastern Ohio, so our concept of irrigation was just waiting for it to fall out of the sky, and it worked pretty well. But I learned very quickly out here that we do have to have these irrigation systems as life support for our different plant material. So obviously, if we're doing lawns, we're going to have those sprinkler systems out there. Tonight, we're going to be talking specifically about the bubbler type systems. Now, bubblers were typically the predominant way that we used to irrigate shrubs and trees before we started using drip irrigation. Drip irrigation, maintenance, troubleshooting, and repair is going to be the class that's next Thursday. So if you're interested, make sure you sign up for that one as well. So when it comes to daily system maintenance, and this is where I'm glad we're in a virtual class, you can't throw anything at me saying to yourself, I spend how many thousands of dollars on this irrigation system and I have to do something to it every day. Well, you're not really doing something to it every day. Really, all you're doing is paying attention. And that's one thing. Really good, experienced, qualified irrigation specialists, they're going to be able to spot a lot of irrigation problems without even turning the system on. So one of the first things you're going to want to do is go ahead and look at the plants. They're going to tell you if there's a problem, and the first thing you're going to check is if it's water. It's not always water that's a problem, but that's the first thing you do want to check. The Landscape Watering by the Numbers brochure that hopefully you all have a copy of. If not, you can actually get a digital copy of it online. We'll go over some of those symptoms. And some of those symptoms can be confusing, because if you've got plants out there where the very brand new leaves out at the ends of the stems, the brand new baby leaves, are kind of wilting in the afternoon heat, that's actually overwatering, not underwatering. Now, of course, if they're kind of turning brown and curling upward, that's probably a sign of underwatering. So you definitely want to learn what those symptoms are. So just by paying attention to your plants, you're going to be able to pick up on things really, really quickly and catch it before it becomes a big problem and you're trying to nurse a really sick plant back to health. The other thing you're going to want to do is look at the ground itself. So I myself still get a newspaper delivered. So as I'm walking out to get the newspaper in the morning, I will glance over into my front yard, especially if I know that drip system ran the evening before. And if I see some wet spots out there where I know there's no emitters, or I see some washed out spots, the leaks are going to be easy to spot. So you're going to see those holes in the ground and all that fine silt laying on top of your granite there. So without even turning the system on, I know there was a drip leak on that poly tubing in that spot that needed to be repaired. So, and again, wet spots where you don't have any emitters, it's time to turn that system on and find out what's going on. The last thing you're really going to do is look at your hardscape. So you're going to be looking at your sidewalks, your driveways, your pool decking, and your patios, and your walls and fences. So you're looking for that staining that you can get from the minerals that are in our water, most notably is calcium and salt. So you can see they've got those sprinkler heads right up against the wall there, and those are the large heads that rotate back and forth. They're out of adjustment, so every time they turn too far, and they actually spray onto the wall itself. So one of the things that's going on there is, yes, they are wasting some water. The other thing that's going on, it's not really the cost of the water that's causing them their biggest problem. The biggest problem is how are they going to make that fence look nice and new again? So if it were a painted fence, they would just keep painting it over and over and over again. Whereas this is a nice colored block, and the only way to get that calcium off there is to do an acid wash. So you get out there with a muriatic acid and a scrub brush, and when that muriatic acid runs down that wall and into the grass, what do you think is going to happen to that grass? That's why on modern landscape designs these days, we do know that sprinkler heads do get knocked out of adjustment. So you'll usually see some buffer zones in between any hardscape areas and any grass. Kind of like our parks in Gilbert. Our oldest park is Freestone Park, and we've got grass right up to the sidewalk on Lindsay Road. Excuse me. And sometimes those heads get out of adjustment and they start spraying into the road, and we get phone calls about it. We do appreciate it. We can't look at every sprinkler head every day, so we've got to go out there and take care of it. Our newer parks always have that buffer in between any turf area and any hardscape. So for monthly system maintenance, what you're going to want to do is go ahead and start at your irrigation controller. There's a couple reasons you're going to do this. Is number one, you're going to ensure the program is correct for the season you're in. This is where a lot of water is wasted, where people are not adjusting their watering schedules often enough, making them water more often in the summertime. And as it starts cooling down, start decreasing that frequency, making water less and less and less often. So you're also going to want to turn the system on so you can expect it during the daytime when the sun is up. We run our sprinkler systems through the middle of the night, making sure that we're losing the least amount of water possible through evaporation. That is one thing about sprinklers. You're throwing water up in the air, so no matter what, you're losing water to evaporation. But watering through those nighttime hours, starting at midnight, you're going to minimize that loss. Now, I know a lot of people from the Midwest are terrified about watering their grass in the middle of the night because in Ohio, that's a really bad idea. You can create some disease and some fungal problems out there. Here, we're in a desert with very low humidity most of the year. A properly watered grass through the middle of the night is not going to be a problem. The other great reason why you're going to start at your irrigation controller to start your inspection process is you're still standing up and you're still dry, and that's always a good thing. So for semi-annual maintenance, what you're going to do, and we'll talk about what you actually do on the individual components of the sprinkler maintenance and your bubbler maintenance here, but we're going to cover the broad 30,000 foot topics right now. But about twice a year, you're going to do a little bit more in-depth maintenance. And one of the things you're going to do is if your controller has one of those 9-volt backup batteries, make sure you replace it. So if you read your manual from your irrigation controller, it'll probably tell you to replace those once a year. Now, what those backup batteries do is if the power goes out, it holds your program in the controller so it doesn't get lost. So when the power comes back on, you don't have to reset it. Some controllers nowadays have what are called non-volatile memory, so no matter what, your program doesn't get lost. And all that battery does is keep the current time and day correct. Some of your very high-end models use a rechargeable 9-volt battery, and if that's the case, replacing it every 6 months is way more often than you need to do it, probably every 2 to 3 years. But what you don't want to do is put a regular 9-volt battery into that controller that does a charge on that battery. You never, ever, ever want to recharge a regular 9-volt or any type of battery for that matter, your AAAs or what have you. So the other thing you're going to do for semi-annual maintenance, excuse me, let me get a drink of water here. That should do better. Is actually when you're turning on the system, open up those valve boxes and take a look for leaks, clean out any excess dirt that may have gotten in there, and actually check those wire connections. So many times you're going to find those valves are actually buried all the way in dirt. You don't want that to happen. You actually really want those valves suspended above the dirt, because in case there is a small leak in there and you've always got that really, really wet soil inside that valve box, there is something in your yard that is attracted to that moist soil. And it is the entire reason why you put in an irrigation system to begin with. And that means I'm not talking about termites or bugs or anything else. The thing in your yard that is attracted to that moist soil are those tree roots. So it got too old and dried out. I don't have the sample anymore because it crumbled away. But I had a sample of an irrigation valve completely engulfed in tree root because it was buried in the dirt and it had a small leak. So the soil around it was always wet. Really importantly, what you want to do is check those wire connections. So what I'm going to do here temporarily is I'm going to drop out of the PowerPoint presentation so you can see me, so I can give you a little bit of real world what these irrigation parts look like and what you should be looking for. So let me do a stop share. There we go. Can everyone see me? Okay, what you want to do is make sure that your wire connections inside your valve box are done with waterproof wire connectors. Very common, what you're going to see in there is the standard wire nuts being used. So what you've got inside here is the ends of those copper wires are exposed, and inside your valve box, even without a leak, you're going to have a lot of condensation and moisture inside there. So that unprotected copper wire at the end of those wires inside that wire nut are going to begin to corrode. Now, the signal coming from your irrigation controller to the valve is very low voltage and very low amperage, so some corrosion here means that the signal will never reach the solenoid of the valve and it no longer opens for you. And that's when you see your plants start going into stress. Now, you can use a type of wire nut. This is a larger one than you would normally use. Let's see if we can get that to focus a little better. If I put it back here, it'll probably work. But this is just a larger one I use because you'll see it has this protection here, and these come filled with the silicone gel, and you use them just like a regular wire nut. You push it on and twist it until it's snug. These do work. The unfortunate thing is if anyone ever does take it off to replace a solenoid, they tend to reuse this and put it back on, and now all that silicone is gone, and it's nothing but a plain old wire nut at that point. That is the #1 electrical failure we see in residential irrigation systems. A better way to do it is by using a more professional waterproof wire connector here. So I've got some of the larger gauge wire that you'll see in commercial irrigation systems. These are called either Pentite or Dry Splice, or some of the brand names out there. And I actually pulled on mine so hard I actually broke the wire connection inside there. But what you're going to do is you're going to make your wire connection inside there, and then you've got a silicone-filled cap you're going to put on there and snap it together. Notice I'm not snapping that all the way together, and that's because if I do, I can't get that apart again. That's why we recommend these, because if anyone does need to make a repair like changing a solenoid, they can't take this apart and reuse it. They have to cut it off, and it forces them to use a brand new wire connector. So let's go back to that PowerPoint presentation and go back to share. Bear with us, this is new to all of us. Okay, there we go. So for annual irrigation system maintenance, and this goes for whether you have sprinklers, bubblers, or drip, and some of these other things as well, is you may want to consider when that backflow preventer was last tested. So this, let me see if I can get my annotate thing here to work nicely for me. And let's make a nice yellow color so we can see it. Actually, let's do that nice bright green. So this little guy right here is called a backflow preventer. And what that does is it makes sure that once the water goes into your irrigation system, it cannot come back into your drinking water. So you can have these tested, and that's what these nice little test ports are for. So a certified backflow tester can come and test that assembly, and he tricks it into making it think the water's running backwards to make sure he can see when the number 1 check valve shuts and the number 2 check valve opens to prevent any of that water from ever coming back to the drinking water side. Now, for commercial irrigation systems that are dedicated landscape meters, and that's the only thing they serve, they're not serving any inside water, any domestic water, where health and safety might be an issue. We require those customers to have those backflow assemblies tested every year. And we'll send them a letter reminding them when it is time to get that tested. And if they don't get it tested, we send them a stern reminder letter. And then if they still don't get it tested, we have to make sure our drinking water supply is protected. Knowing that we're not going to affect human health or safety, we will go out and shut off that water meter and lock it. And they're not allowed to have water for that landscape again until they get that assembly tested and prove to it that it works. We
Excuse me,
ask
Jeff.
the residential. Yes?
Excuse me. Before you go any further, I didn't want to interrupt you during the backflow stuff, but somebody had asked, so this is before you were talking about the backflow, is it pen type or dry fit? Does that make any sense to you?
Yes, they're asking about the brand names of that more commercial grade waterproof connector, and it's pen tight, T-I-T-E, or dry, D-R-I, splice.
Gotcha. Thank you, Jeff.
You bet. Now, we don't require our residential customers to have those backflow preventers tested every year. And the reason for that is there are a lot of residential backflows out there. And if every one of you tested them every year and sent in that paperwork, we would never see those poor people that work in that department again. And in a residential scenario, having that assembly tested every year is overkill. But if it's been maybe 3 or 5 years, you may actually want to consider having that tested. Now, on the one I'm showing you in the photo here, you can actually see some of that calcium and deposits left on there where that assembly was leaking out of that number 2 check valve on top, underneath that brass metal cap on top. So that tells me that that assembly was not working properly when it was having that problem. But there's another check valve inside there that if it malfunctions, you don't see that leaking on the outside. Now, there are a couple other ways to do backflow prevention. You may not have one of these, so we're going to drop back out of the presentation here. There we go. A different way of doing backflow prevention, it's not the preferred way, is by using what is called an anti-siphon valve. So this is an irrigation valve, and this is a type of backflow preventer that's always attached to this valve. This is called an atmospheric vacuum breaker, and underneath this cap here is an open vent to the inside of the pipe. So inside on here, there's a low gravity operated poppet. So when the valve opens and the water begins flowing through, it pushes that poppet up and seals the vent. So all the water goes out to your irrigation system. Now, when the zone shuts off, this drops off the pressure, that poppet drops back down. So that creates an air gap. So that way, if it ever tries pulling the water backwards, that air gap prevents it. So this does work. However, this cannot be tested like the other type can. And because it's just a gravity operated poppet in there with the minerals in our water, so let's hold this up so you can see it a little bit. See how that poppet moves up and down there just by gravity. With the minerals in our water, I've opened these up before, and those have been in the closed position all the time. Even when I took the cap off, it was closed. So the preferred way to do it is with that first type I showed you in the photo, which is a pressure vacuum breaker, as opposed to these anti-siphon valves that use an atmospheric vacuum breaker. Very important on this style, though, is you cannot have any valves downstream that shut off the water. If you do that, this area is always under pressure, so it never creates that air gap, and it can't provide its function of stopping that backflow. Which means, in some cases, unfortunately, we see people using these as their backflow preventers. This is a manual anti-siphon device, but they think it's the heavy-duty one because it's made out of brass. If you listen real close, you can hear that little poppet moving up and down when I shake it. So we will see these installed with irrigations valve downstream. This is not going to do the job to protect your drinking water. Now, these backflow requirements are code, but honestly, that code is the least important reason to make sure you're doing this correctly. This really is about the safety of your drinking water. You know, we use fertilizers and pesticides and insecticides out in our yards. Even if you're doing everything natural and organic and you're doing composting and things like that, if you're doing composting, you know better than anybody what's in that, and I'm pretty sure you don't want to drink it. So make sure you have your backflow prevention done correctly. Okay, let's go back to share screen. Still learning where all the buttons are. Okay. So now let's talk about what we want to do to maintain these bubbler irrigation systems. So these bubblers are kind of like miniaturized or localized flood irrigation systems. So what we're doing is we're delivering the water very, very quickly, and we're controlling the water in these wells. And let me get a nice color on my little drawing thing here. So what we're doing is we're building these berms around there. Hard to run my mouse here on my little table. And we're filling that up very, very quickly with the water and then allowing it to soak in. Now, it does have a slightly less efficiency than drip irrigation because while we're waiting for that water to soak into the ground, we're losing some of that to evaporation, and we don't have that nearly as much of a problem with our drip irrigation system. However, bubbler irrigation systems are still very useful for large, high water use plants, and there's something in our valley that many people really enjoy growing, and they do grow well here, but they need a lot of water compared to our desert plants. And those things are citrus trees. It is very, very difficult to water a mature citrus tree with drip irrigation and provide it with enough water. When you've got a 20-foot wide citrus tree, when you water it, you should be giving that tree somewhere around 250 to 280 gallons of water. Drip emitters deliver their water in gallons per hour. That's a lot of emitters to make it so it's a reasonable runtime. You're going to need 40, 50, 60 emitters around there. Whereas bubblers deliver their water in gallons per minute, so it'll fill up those wells very, very quickly, usually 15 or 20 minutes. So drip irrigation delivers the water in gallons per hour, so you program those times in hours. Bubblers and sprinklers deliver the water in minutes, so you're programming in minute increments. So for monthly bubbler system maintenance, you're going to make sure the bubblers are flowing at the proper rate. So there's a picture of a bubbler in operation, and you see it's putting out the water at a pretty good rate. Now, some of those are preset and some are adjustable. And I know people like having those adjustable things out there, but really the best bubblers to use are the preset ones that do pressure compensation. So let's show you what a couple of these bubblers look like and how you would adjust an adjustable bubbler. Go. So your bubblers are mounted on PVC pipe, just like your sprinklers, and they're on these rigid risers that are always sticking up out of the ground. And this particular one, the more I open it, the more water comes out. The less I open it, the less water comes out. So a lot of people think this is an advantage, so they can really kind of play around with the different deliveries of water, plant by plant by plant. One problem with that, though, is you don't know how much water in gallons per minute you're delivering to each plant. And if you look at our watering information we provide to you in our Landscape Watering by the Numbers brochure, we tell you how many gallons of water to give a shrub or a tree based on its diameter, how wide it is. So, okay, I got this plant, I want to give it 12 gallons of water. How much water is coming out of this in gallons per minute? I don't know. That way, we have no way to make that correlation and come up with a good runtime to program in the controller. The other issue with these adjustable bubblers is they get knocked out of adjustment very, very easily. And if you have kids around the home, boys in particular, I speak from experience, if you have something out there that can be turned, they will find it and they will turn it. And now the next time your bubbler zone comes on, it floods half the backyard. So some bubblers we used to use in the commercial application to make sure they didn't get knocked out of adjustment actually required you use a Phillips head screwdriver. So these work really well and they stay at the setting that you want. But one thing that people don't like about these is when they do want to go out and make an adjustment to them, they find they have to go back to the house and get the screwdriver they forgot to bring along with them. The better ones to use, though, are the preset ones, and these do what's called pressure compensation. Whenever you move water through pipe, you lose pressure. That means your last bubbler has less pressure than your first bubbler. So less water will come out of it unless it does pressure compensation. A pressure compensating bubbler within a range of pressures will still put out its rated flow. 1/2 gallon per minute, 1 gallon per minute, 2 gallon per minute. Those are typical flows that you can get these bubblers in. That way I know exactly 2 gallons per minute is coming out of this. I want to give it 12 gallons of water. That's a 6-minute run time. It's easy to make that calculation all of a sudden. Okay, there we go. Okay, the other thing you want to do for bubbler maintenance or maintaining these bubbler irrigation systems is go ahead and turn it on in the daytime when you can see it and make sure there's no leaks or damage to the bubblers themselves. The risers are rigid. It's a Schedule 80 PVC that these are mounted on, but if they're hit hard enough, they can break. And make sure you don't have any pipe leaks. These are on PVC pipe, which is a more durable material than that poly tubing we use on our drip systems, but it can still get breaks in it. So you want to go out there once a month, turn it on, make sure everything's doing okay. The other thing you want to do is make sure your runtime is correct and the water is not overflowing the basin and watering outside of the area you want to water. Now, most people will actually use real nice hardscape materials like bricks or flagstone or something like that to make their berms. Whereas my lemon tree in my backyard, I'm not that fussy about it. I just got some old-fashioned dirt berms built out. I just raised up the earth around there with some soil. And over the course of time, those kind of tamp themselves back down. So if I don't pay attention to it and keep those berms well maintained, just like in those old flood irrigation neighborhoods, when those berms aren't maintained, the water goes out over the sidewalk and into the street, and it's not where they want it to go. So you just want to make sure you're watering where you mean to. Also, if you have any PVC pipe that's exposed above ground, you want to get that back below ground. If you've got the PVC exposed to sunlight, it will actually begin to deteriorate and turn a brown color. We call that sunburnt pipe. What's going on there is the sunlight, the UV radiation in our sunlight is actually degrading the PVC plastic. And we see this typically done on backflow installations where they aren't using copper pipe to bring that water back below ground. PVC is easier to work with. You don't have to use a torch and solder. But over the course of time, that pipe that's above ground and getting all baked by the sun, that part of the system is always under pressure by your backflow preventer. And it also gets a lot more pressure every time an irrigation valve shuts off. You get a pressure surge in there up to 1.5 times your normal pressure. So that sooner or later is going to burst. So if you've got those backflow preventers or mounted on PVC pipe, really recommend that you get that changed out to copper, then you transition to the PVC pipe underground. So that's pretty much it for monthly bubbler maintenance. There's not much to do. For semi-annual bubbler maintenance, what you want to do is make sure you're watering in the right place. And one thing I want everybody to always switch their mindset on this, change your focus. When you run your irrigation system, you are not watering plants. When you run your irrigation system, you're watering roots. So that means when this tree was first put in the ground and it was a baby little tree, the root zone was only that big. So they made a little 3-foot wide berm around there to capture the water. I'm going to move my mouse so it works better. There we go. So we got that there. But now we've actually grown and we do not want to water here anymore. We want to encourage a nice deep wide root system. So what we're going to do, instead of continually widening out the berms, and this is what some people will do, is they will just kind of keep moving these berms out and out and out. But one thing you realize is you actually don't want to water in this area anymore. So what you're going to do is instead of continually expanding the berms, after the tree gets big enough to outgrow the need for that original basin that you've built, you're going to construct a second set of berms. So it looks like that. So what we've got going on here, let me find my little drawing tool again here. These are the original berms we created. We just created a secondary set of berms here. and move the bubbler to here instead of here. And this is also very good to do with citrus trees, because if you keep that area of the trunk wet right where it comes out of the ground, where the roots become the trunk of that tree, that is called the root crown. And there's a disease out there called crown rot, and citrus trees are susceptible to it. So constantly keeping this area, that root crown always wet, you're going to eventually damage and possibly kill that tree. So we actually want to move those berms out and water out at the edge, close to the drip line of the tree, because that's where the water absorbing roots are going to be. Your thick woody structural roots underneath the canopy of the tree do not absorb any water. All the water absorption happens at the ends of the roots. And not only do you want to protect that citrus tree from getting that crown rot, you also want to make sure you're growing the roots to the tree, because the roots of the tree does absorb the water and the nutrients, and that's all wonderful, but the roots also hold the tree upright in the ground. That is the number one reason why we have so many tree failures every time there's a storm here in the valley, is people are not irrigating to grow roots. They never move the watering out away from the bases of the trees. Now, our desert adapted trees are a little bit different. Sometimes they will say, I've got all the water I need right here, so I don't need to grow any roots. So the next time we have a nice big windy storm out there, watch that evening news. Some reporter will be somewhere out there standing next to a tree laying on the ground. Look at the roots or the lack thereof. So I know it's kind of hard to see what's going on from this viewpoint here. So my next slide will show what it looks like from overhead. We've got our original tree here, and we've got our original berm in the middle. That's that inner circle here. So this is our original berm where we watered the tree when it was a young baby tree, and that's where the roots were. Later on, we constructed this other berm out here. And we moved the bubbler from here out to here, maybe even added in a second bubbler over here because now it's a bigger tree and we're delivering more water to it. But you'll see what's going on here is we have the shape of a donut. And what we're watering is the donut, not the hole. Okay, let's talk about lawn system irrigation maintenance. Lawns are some of the highest water use plants that we do use in our landscape, except for citrus trees. Those are actually thirstier, but that does not make our lawns bad. Lawns are actually the only plant material that tolerates foot traffic. So if you've got a play area out there for the kids, grass is the appropriate choice. That is actually incorporated into our principles of xeriscape. But we say have your lawns appropriately sized. You don't need 20,000 square feet of grass unless you're going to father your own baseball team, and have it appropriately placed. Put it where it's actually going to be played on. I wonder why we still see these little postage stamp front lawns out there, these weird shapes, these little kidney shapes out there, and you never see them get played on whatsoever. You do see them get them walked on once a week, every week, with the guy pushing the lawnmower. Other than that, they're just sucking up excess water and not actually being utilized for what they should be used as. So with proper maintenance and management, though, we're only going to apply the water that's actually needed. So we got a new category here for weekly sprinkler maintenance. And what we're doing here is just making sure that when we did our mowing that week, we didn't damage any heads, accidentally clip off any nozzles. So we refer to this as geyser checks. So this is what one of our water efficiency checkups at one of our residents in Gilbert. I made sure you can't see whose house it is. So you've got a broken sprinkler head there, and they've got really good water pressure in that neighborhood because that water is shooting about 35 feet up into the air. So everyone that sees this picture says, oh my gosh, look at how much water they're wasting. Well, look at where the water is actually landing. It's landing in the pool. So they don't have to use their pool autofill. Now, there are some other problems that are going on with this broken head here. When you have that broken head, now there's less pressure on the system for the other heads to operate, and you're not getting your good coverage in here, so you're seeing that lawn area start to stress. And one thing that people tend to always do when they see a little bit of stressed areas in their lawns, the first thing they do is run to the timer and increase the runtime for that station to make that stressed area go away. Well, in this scenario, you increase the runtime and all you're going to do is fill your pool even more. The other thing you're going to do for weekly sprinkler maintenance is make sure the nozzles are directed properly. So if you do have some sprinklers that are kind of right up against the edge of your patio right here, so let's say that's your patio, you've got a sprinkler head here with a half pattern nozzle, sometimes they get knocked out of direction. So they end up watering the patio and they're not covering the lawn as much. So what they end up looking like is something like this. Come on. There we go. So now you'll see, still getting the hang of this drawing tool. Here's our sprinkler head, but now we're actually watering the patio, and we got that nice, beautiful brick or flagstone patio that we paid a lot of money for, and we're now staining it with the minerals that we do have in our water, that calcium and salt. Additionally, we're no longer getting coverage from this sprinkler head in this area, and if you're really tight on that water management, you're going to start to see some stress out there. If you try and fix that by just increasing the runtime, all you're going to do is put even more water on your patio. So actually turn the system on and find out what's going on. If you've got a grass area that used to be all nice and green and healthy, and now you've got one area that's showing some stress, find out what's causing that stress. Don't just automatically increase the runtime. It can be something as simple as this. Because remember, watering the patio doesn't do anything for the lawn. So another thing you're going to do for monthly sprinkler maintenance, now that we're out to that period, is definitely turn the system on and actually take more of a careful walk around and check for leaks or damage to the heads, risers, or piping. And also, it's a good idea to actually check this and actually run those sprinklers for your normal amount of time that you normally run it, for how you water, and make sure the water is not running away, especially on those front lawns where it runs over the sidewalk and down the street. So I know we do have transportation issues in the valley. We just can't seem to make the streets wide enough, fast enough for all the people that want to live here. But I promise you, watering the streets does not make them grow. And that's water that you paid for that you are literally throwing down the gutter. So check and make sure you're not having any runoff problems. These sprinklers put down the water more than 10 times faster than our soil will take in. So if you were at last week's class learning how to program those irrigation timers, you learned how to do that cycle and soak programming. So if I wanted to run my sprinklers for 27 minutes, but I can't do it all at once, what I'm going to do is 3 cycles of 9 minutes an hour apart. So I cycle 9 minutes and let it soak in for an hour. Cycle another 9 minutes at it, it's going to soak in and not run away. Soak for another hour, cycle my last 9 minutes on there, and that's how you water your grass deeper and less often in the summertime, so you're not watering every day to prevent runoff. A deeper rooted lawn is a healthier lawn. So once again, watering the patio does nothing for the lawn. There we go. You also want to make sure those nozzles don't get partially clogged. So one of the things that's going on out here, let me show you kind of what a sprinkler head typically looks like when it's connected to some piping, and show you what that nozzle looks like. So let me drop out of my share screen here. But one thing you will see before I do that is the little slit where the nozzle, water comes out of the nozzle. You may get a tiny little grain of sand there that's not very big, but the farther you get out into the watering pattern, the bigger that gap gets. So let's do a little stop share here. There we go. So very typically, your sprinkler heads are mounted on these risers, and then these just screw into the fitting on the PVC pipe. So we just screw that in there. The sprinkler head is just screwed onto the riser. And we're going to talk about this riser I'm showing you in just a moment. This is what we call a cutoff riser. Actually, I'll show you now while I actually have the screen up. And if you look carefully, if I hold it still long enough, my camera will focus on it. You're going to see at different spots along there, there are gaps in the thread. And that's so we can cut it off to different lengths to make sure that head is at the right height. Now, when it comes to how the water is coming out of the nozzle itself, trimmed my fingernails this morning, so this is hard to do. Well, that's a quarter pattern. Yeah, we'll use it. Real careful. I'm going to try and show you here. Hopefully you can see it, but there are some little slits where the water comes out. So those can get partially clogged up, and you're going to have what we call a fingering nozzle. It's going to look like a bunch of fingers coming out instead of the nice even fan spray that we want. What you don't want to do, what we see landscapers doing all the time when they see that nozzle partially clogged like that, is get out the handy dandy knife and start digging around in there. You have now destroyed the nozzle. It's time to replace it. You've destroyed how evenly it's going to apply the water in the area that it covers. So when we get to the repair section, we're going to show you how to replace those nozzles. Let's go back into our share screen here. There we go. And really quickly, I'm going to screw that head back on there so the next time I show it to you, it's already where I want it to be. There we go. I'm trying to do this on my coffee table. It's a brave new world that we live in. And if I tried to do this in my office, I wouldn't have any area to hold all these different pieces that I want to pick up and show you. So rather than going out and trying to find pictures of all this stuff, we wanted to actually break out of the presentation and show you what these things really look like. So the other thing you want to do for sprinkler maintenance is make sure the sprinklers pop up above the height of the grass. For some reason, well, I know what the reason is. They cost a little bit less money. People are using sprinkler heads that only pop up 2 inches in height. So you mow your grass at 1.5 inches in height, and before you mow it again, the grass is taller than the head pops up. And what's going to happen there is all the water is going to get blocked by the grass right here. Oops, let me change my color on that. There we go. All the water that comes out of this head is going to be blocked right there. So this area is now no longer getting coverage, and you're going to start to see some stress out here. And this area here is going to be a muddy, wet swamp because that's where all your water is going. The way to correct that is to use a sprinkler of the head that pops up higher. You want to use at least a 4-inch pop-up sprinkler. In most cases, that's as much as you need to go. Some people actually use 6-inch heads. I think that's generally a little bit more than they need. But then again, I don't know how tall they let their grass grow, so maybe they really do need a 6-inch pop-up head. The other thing that you can see out there sometimes happens is we've got some plant material planted around the edge of our lawns, and all of a sudden you've got branches from those untrimmed plants coming over and covering up that sprinkler head. And you say, gosh, I've got this brown area up here, and I keep turning up the runtime more and more and more, but this brown area is not going away. What you want to do is prune your plants back out of the way so the water comes from this sprinkler head and reaches out where it's supposed to go. The other thing you want to do for monthly system maintenance is make sure the heads are perpendicular to grade, to the ground that they're mounted on, and they're at what we call grade level. So let's make sure I've got the right color here. The top of your sprinkler head should be even with the soil. If it's sticking up too high, you're going to catch it with the mower. If it's down lower than this, if it's down too low here, every time this part of the pop-up stem retracts, it drags dirt across a wiper seal, which I'm going to show you in just a moment when we break out of the presentation again. And then you're going to have that one head that every time the system shuts off, you got that one head that doesn't pop back down until you go over and tap it with your foot. So that's that pop-up stem is being degraded and messed up by that dirt being dragged across every time it tries to retract. You also want it nice and perpendicular to the grade that it's on. You don't want a tip sprinkler head. And these are the things that we want to look for that your landscape contractors typically don't pay attention to. Those guys typically, what they think irrigation maintenance is leak response. I've got a broken sprinkler head. I've got a broken pipe. I've got a blown emitter. I've got to fix that. They're not paying attention to these little things that have a huge impact on how efficient your irrigation system is. And the more efficient it is, the less water it uses to keep your grass nice and green and happy and healthy. What you don't want is a tipped head that looks something like this. So you're going to say, wow, this is actually pretty good because I'm getting really good distance on this side. But now you're not reaching over to the next sprinkler head, what we call head-to-head coverage on this side, and you're going to start to see that stressed area. You're also not getting any of the close-in watering from the head over on this side, So you're going to start to see a little bit of stress in that area as well. You can fix that with the plus button. You don't fix it, but you make the brown spots go away, but at the cost of a much higher water bill. And these other areas that were getting the proper amount of water with that increased runtime are now being way over watered. And that's not what you want to be doing either. So what I'm going to do is I'm going to show you that wiper seal, and I'm going to show you a better way to connect your sprinkler heads to that piping. Okay, there we go. So like I said, the most common way we see these sprinkler heads done, and I haven't cut this one yet, so I got to hold it way back here to see what it is. You've got the different spots on the thread where you can cut it off to the different lengths. You want the top of the sprinkler head even with the soil. Not too high where you're going to hit it with your mower, and too low. This particular model sprinkler head shows that wiper seal real nice. That's that white band around there. The part that pops up, that little pop-up stem, is actually slightly tapered. So as it first begins to rise, any dirt or debris that's around there gets flushed away. So what's going on here? Give me a second here. I'm going to cheat and pull this out of the body and just push up on this spring. So what's going on here is when it's fully extended, that's when it makes the seal down here. And then when it retracts, every time it retracts, if this head is too low, it's going to drag all that dirt that's next to the head right across that seal. And then you've got those stubborn sprinkler heads that don't pop down until you go out and smack them down. So once you replace that head, what you're going to do is you're going to make sure you get it at the right height. And that is one issue with these cutoff risers, is you've got a pretty big gap between that one and that one. So sometimes it's real hard where you're going to be a little too high or a little too low. There is a better way to hook up a sprinkler head, and that's by using what we call a swing joint. So you buy these pre-assembled. They screw into the pipe just like your regular riser does, but they've got some elbows on here and a little length of tubing, and then our sprinkler head just screws onto this end just like a sprinkler head. But now I can set it at exactly any height that I want. I'm not restricted to where those gaps and those threads are on those cutoff risers. The other thing that can happen, I talk about those little short 2-inch pop-up heads that don't pop up high enough to water over the grass. That's a flush nozzle, not a regular sprinkler nozzle. A lot of times what you'll find is people will do this because they realize if they use a real short riser, they don't have to dig the trenches deep to install the pipe. So now you learn from this class, well, really what I want to use is a 4-inch sprinkler head, but when I attach a 4-inch sprinkler head, now it's sticking way up above ground. So you say, well, there's nothing I can do. I'm stuck with these little 2-inch heads. The other thing a swing joint does for you is it offsets the head to the side of the pipe. Let me see if I can get a good angle here to show you. So I can actually put that down to where the bottom of the head is lower than the pipe itself. Let me turn around this way, you can see it better. So now I can fix that problem of those short sprinkler heads with that shallow pipe. The other thing is now I've got a flexible connection between the sprinkler head and the pipe. And if you still do have those front lawns, like right next to your driveway, you have that friend that comes over, has one glass too many. As he's backing out of the driveway, he runs over your sprinkler head. This rigidly connected head, if he does that, he may not only break your sprinkler head, but now you've broken the pipe as well. If you need to dig a hole to replace a sprinkler head, it's going to be about this big around. To dig a hole to do a pipe repair, it's going to be about this big. So if you're connecting your heads with this swing joint so it's flexible now and he runs it over, he may break the head, but you won't break your pipe. The other thing is sometimes we don't get those fittings glued in straight when we install the system. Well, now the head is going to be crooked no matter what. Actually, with the swing joint, I can fix that. I've got a full 3 ranges of motion that I can move this head around and get it placed exactly where I want it. This little swing joint right here, that's going to add about $1.50 per sprinkler head to your irrigation system. Not going to break the bank. Now, while I'm out here and talking about sprinkler heads, a lot of people will ask, well, who makes a good sprinkler head? Does Rainbird make a good head or does Hunter make a good head? The answer is yes. All of them make good sprinkler heads. This one is a Rainbird 1800 series sprinkler head, and it is a very good high quality head. Toro makes a great sprinkler head. They're 570. I think I have one here somewhere. Irritrol also makes a pretty good sprinkler head. But as far as Rainbird making a very good sprinkler head, they also make this that you buy in the home improvement store that is very, very inexpensive. It only pops up a couple inches in height, so now it's not going to spray over the top of your grass. And the other thing is if you ever take it apart and look at it, the thread, hopefully you'll be able to see this. I know it's hard with this camera when I'm moving things around. Let's see, where's that gap? There it is. You'll see the thread doesn't even make one complete revolution around the body of the sprinkler itself. I know it's a little hard here. Let's hold it a little further away. Hopefully that'll make it easier for you to see. Whereas opposed to this other higher quality sprinkler head, whether it's a Rainbird, a Toro, or an Irritrol, or a Hunter, now you can see all the threads that are on there. That's a very nice secure connection between the cap and the body.
Hey, Jeff.
Yes.
We have a question about the swing joints. Are they available at local hardware stores or just irrigation specialty stores?
You're likely going to only find them at the irrigation supply stores, and I believe I have them all listed at the end of the slide, so you'll get to see it again. But the common ones out there are places like Ewing, EWING, Horizon, Sprinkler World, and Site One, SITE-1, ONE. Again, I've got those on a slide at the end of the presentation, so you'll be able to see those again. I wish they would sell those in the home improvement stores because that's where many people go to get their equipment. And I don't have anything against the home improvement stores. I've been in the industry for over 30 years, so I can go there and I know which products are okay to buy and which ones I should avoid. So by going to the irrigation supply store, though, not only are you going to be, they also do sell some of the lower end stuff you should stay away from. But one thing with the home improvement stores, some of those people that work there, they're very knowledgeable on irrigation. Some of the advice I hear being given out in those aisles on Saturday mornings when I'm in there makes me think I bet he's really good at fixing toilets because he doesn't know anything about irrigation. Those people that work in the irrigation supply stores, most of them have years of real-world field experience working on irrigation. So they're going to be a great resource for you as far as answering questions. We're not going to be able to teach you everything in just about 45 minutes here. Let's go back to our presentation here. Yep, there's a button down there. Okay. I haven't done this one yet where I've tried to shorten it to that 45-minute runtime, and I'm not paying attention to time, so I don't know if I'm doing a good job or not. Okay, so there's all the maintenance. So now let's go ahead and talk about some troubleshooting. When you're doing your maintenance, you're going to be catching those problems before they become big problems, but even with a good maintenance regimen, things go wrong. You're taking care of your car, you're rotating tires, you're changing your oil, you're changing your spark plugs, you're bringing it in for the 30,000-mile maintenance, and then the alternator goes bad. That's just the way it is, and irrigation systems are no different. So this section I actually have called, Why is my controller acting so crazy? For a few years, I worked at a Rainbird Tech Service call center. So I would offer technical support for people having trouble with their irrigation system, calling from all over the country. And almost always those calls started out with the sentence, my timer doesn't work. So that's the part that they can see that's above ground. They don't understand that 99% of the irrigation system is actually below ground. So more often than not, it's a programming error or the real problem is actually going to be somewhere else in the system. Oh my gosh, I'm at almost an hour, I see. I'm going to try not to speed through this too quickly because I do know you want to get this information, but we probably only got about 5 to 10 minutes more on this, I would guess. Okay, one of my favorite calls I ever got was this sweet little old lady who was certain her controller was possessed under some sort of demonic possession. And that's because their irrigation kept running itself over and over and over again. The cause on this one, it's not a faulty timer, it's a programming error. She put in too many start times. She did not realize that one start time will run through the cycle of all stations in that program, one after the other, and then stop. So what she did is she had it set for Monday and Thursday, had 3 stations watering for 15 minutes, and if she wanted it to run one cycle of those 3 stations, one start time will do it. So now what's going on here is on Monday morning at 5 a.m. Let me get my other color here. Every time I get out of there, it changes color on me. Station 1 waters for 15 minutes. Station 2 waters for 15 minutes. Station 3 waters for 15 minutes and then stops. But she thought she had to put in an extra start time there, and it won't let me advance the slide when I'm doing my annotate. She thought start time number 2 started station 2. So now what's going on in this scenario, and actually before I go any further, let's bring in her third start time, because she thought it started station 3. Those are not station starts, those are cycle starts. So when she did this, beginning at 5 a.m. with that cycle start, it ran through 1, 2, and 3. It realized there was another start time there, so it watered 1, 2, and 3. And of course, there's a third start time there, so it watered 1, 2, and 3. So that means each of her sprinkler stations were actually running 45 minutes, not 15 minutes. Now she's having a problem with runoff because it really can't run 15 minutes. If she set those for 5 minutes and move those start times an hour apart, each one of those would cycle 5 minutes. An hour later, they would come on and run 5 minutes, one after the other. And at the end, she'd have her full 15 minutes she wanted. Okay. The irrigation seems to run at strange times. I know I set it to come on at 5 in the morning, and in the middle of my afternoon barbecue, it came on. Can be a programming error. If you accidentally input either the wrong AM or PM on either your current time or your start time, it's going to come on 12 hours differently than you thought it would. Another thing that will cause this is there was a power failure and your backup battery is dead. When the power came back on, your timer thought it was midnight, and the factories put in that default start time for early in the morning, like 7 a.m. So 7 hours later, after the power came back on, is when the irrigation came on. So they do put in a factory default program if that happens, to where every station waters every day for 10 minutes with one cycle. They want to make sure at least something happens with the irrigation. It's probably not the right amount, but at least some water's getting out there until you figure out the problem. Another good one is the controller won't respond to any of the buttons. No matter where you turn that dial or how hard you push that button, nothing changes on the display. So what's going on here is that little computer microprocessor inside that controller has gotten locked up. And what do? When to get that power surge it causes that, how do we fix a computer that's become locked up? We reboot. There's no Control-Alt-Delete keys on an irrigation timer, so you're going to remove the power, either turn off that circuit breaker or unplug it if that's how your controller gets it. But don't forget, there's something in that controller designed to hold anything on that chip if there's no power to it. Remove the backup battery. Usually about 30 seconds to a minute, power it back up. That almost always clears up the problem. If not, it's time to contact your manufacturer and see if it's still under warranty. Another good one is one station won't stop watering. Another favorite call at Rainbird because, the guy left for work in the morning and his sprinklers were running just like they should. And when he came home from work, he followed a river of water in the street all the way to his house because those sprinklers were still running. The cause on this one can be a programming error. Be careful how you set your timers and the syntax. We had a customer that water use went way up and his lawn was underwater. And when we looked at his timer, the runtime for his sprinkler station, it was 3:12. And he said, yes, I'm watering for 3 minutes and 12 seconds. And I said, no, you're watering your sprinklers for 3 hours and 12 minutes. So learn how to program your timer. It could be a valve failure, and that's actually what this person's problem was. So first things first, turn the controller off. If it's still running, the problem is in the valve and has nothing to do with the controller. Another good one is one station won't water. The cause on this one could also be a programming error. Make sure you didn't forget to program runtime for that station or that valve somewhere in some program. Now, this could be an electrical failure. These valves are connected to the timer by wires, but they don't actually open with some motorized gate in there. They actually use the water itself to open and close, so it could be what we refer to as a hydraulic failure. So first you're going to check your programming. Then you're going to go out and manually actuate the valve. We're going to show you how to do that. All of your irrigation valves have a way to manually open them independent of the timer. If none of the stations water, once again, check your programming. Make sure you didn't forget to put a start time in somewhere. If you missed us putting a start time in, it's not going to run. And then again, it could be an electrical failure or a hydraulic failure. Check your programming. Check your rain sensor if you have one. So the rain sensor will automatically sense when it's wet and stop the irrigation from running from the timer. But if somebody was playing with a garden hose in your yard, does that rain sensor know the difference between rainwater and garden hose water? Probably not. Most of your newer timers, you actually have a bypass switch so you can temporarily bypass those and then see if it works. So again, go out and manually actuate the valves. My valve doesn't open. Most people are okay. They can replace the sprinkler head. They can fix their poly tubing, no big deal. But when there's a problem with a valve, they feel it's way beyond them and, oh my gosh, I better call in a professional. You won't believe how simple these valves actually are. Step one, is the problem electrical or hydraulic in nature? Manually activate the valve. If the valve opens, the problem is electrical. If it doesn't, it's hydraulic. Electrical valve problems if they don't open. The wire connection at the valve is corroded. Somebody used wire nuts instead of waterproof wire connectors. First thing to check before you start digging anything up. It could be the controller is actually gone bad and it's no longer supplying voltage to that terminal. The little internal circuitry there may have gone bad for that specific terminal. Hopefully you have an unused terminal in the controller and you can just move it to that next one and use it that way. It could be the wiring between the controller and the valve is damaged, and it could be the solenoid is bad. I put that last on the list because everyone does a replacement of that as their number one response, and it's not always what the problem is. It can be. If the valve won't close and it's electrical, it's a programming error, or the controller is constantly supplying voltage to that terminal, that is another malfunction that can happen with controllers, though it is rare. So the way controllers are hooked up to the valves, so you've got your terminals here, 1, 2, and 3. They correspond to valve 1, 2, and 3. So you've got your red wire for number 1. All your solenoids have 2 wires. This is AC voltage, not DC voltage. You'll have another terminal marked C, COM, or common, and that wire is connected to one wire of all the solenoids on the valves. I'm going to show you a valve in just a moment here. But this can help you with troubleshooting because if you've got a wiring problem that is only affecting valve 1, it's this wire or that connection. If it's affecting all of your valves, is there just an erase button or do I have to completely get out of this every time? Okay. Anyways, if it affects all of your valves, it's going to be your common wire. So not so hard anymore. So hydraulic valve problems, if the valve won't open, check to see and make sure somebody didn't shut off the water at that backflow preventer. Maybe you had a pipe break and a leak out there, and your neighbor thought, oh my gosh, I better turn that off for him, and so he doesn't waste all that water, and then he just forgot to tell you about it. Look for the easy things first before you grab the shovel. Could be dirt or debris in the valve. If the valve won't close, it's either dirt or debris in the valve or a hole or a tear in the diaphragm. So I'm going to give you a real quick diagram of what an irrigation valve looks like. Let me get my little drawing tool here. So you'll see our incoming water here is always trying to push up on that diaphragm. Well, there's also water in the top chamber pushing downward. That's what holds it closed against this seat to prevent the water from going out to the zone. Now, when the valve gets a signal from the timer, this is our solenoid with our 2 wires coming off. This little plunger moves up and opens up this port right here. You're going to see this on a live valve in a moment. So that takes water out of the top chamber and puts it downstream. So now there's less pressure in this top chamber. The water itself pushes open the valve and causes it to open. So now our water is flowing through the valve, up through there, and out into the zone. It's also trying to refill that top chamber through the hole in the middle of the diaphragm, but it's bleeding out at the same rate through that port. Now when this solenoid stops getting the signal from the valve, the plunger closes that port. Your top chamber refills and that pushes the diaphragm back down. So let me stop a screen share here, and I do apologize. I see it's 7 o'clock. We really wanted this presentation to only be about 45 to 50 minutes, but this is an irrigation valve and it's a pretty simple thing. This part right here is a solenoid. These normally have 2 wires. One of mine broke off because it gets carried around a lot. And inside there is just a spring-loaded plunger that opens and closes that little port that I showed you on the diagram. So instead of automatically replacing the solenoid, if you do need to replace a diaphragm or something, oh, that's one thing I was going to show you is how to manually activate the valve. I apologize. Let me do that real quick. Put my solenoid back on. Many of the modern valves out there allow you to do what's called an internal bleed. They will have like a little lever or something on the solenoid where you turn that about a quarter turn, and then that allows the valve to open. You've opened up that port underneath there. Another way to do it is many of your older valves will have also this little screw off to the side. That's called a bleed screw. So if I open that up about a half a turn or so, water will start spitting out of there. That's taking water out of the top chamber of the valve, less pressure. Now the diaphragm pushes up, valve opens, and water goes out. So if you have to replace your solenoid, that's easily unscrewed and replaced. Make sure you use waterproof wire connectors. Also turn the water supply off to the system before you take that solenoid off. Otherwise, you're going to get a very big wet surprise. And then you're going to have a series of screws on the top of the valve. I've got most of these removed. And let's go ahead and pull what we call the top or bonnet off the valve. Inside there's a small spring. Don't worry, it's not going to come out, shoot you in the face and hurt you. And inside is a diaphragm. That's all that's going inside of these irrigation valves. Any of you can fix an irrigation valve, I promise you. So let's get back to the presentation as quickly as we can, because I do want to show you some things about repairing sprinkler heads and things like that. Okay, why aren't my sprinkler heads popping up? First question I'd ask, is this a new system that has never worked properly, or is it an old system that, if it's a new system, you may be running too many sprinkler heads at once. Whenever you run water through pipe, you lose pressure. So you've got this system that works great. I've got 3 sprinkler heads on it. Now I put 8 more sprinkler heads on it. Can that pipe grow to carry more water? The way it tries to make up for it is it tries to run that water faster and faster through that pipe. And the faster you run water through pipe, the faster you lose pressure. So that may have been the problem, is just a bad design. Could be the pipe size was too small. People think reducing the pipe size increases the pressure. That's actually backwards. Increasing the pipe size slows the water down so you don't lose the pressure as quickly. If it was an existing system that used to work but now doesn't, you've lost some pressure somewhere. So it could be the flow control knob on that valve has been shut down. And I didn't show you on the valve, but some valves do have the big knob in the middle that you can turn that down to restrict how far that diaphragm opens. Those generally should be left pretty much wide open, or at most 1 turn down, and that's generally only for drip irrigation valves. Could be a broken pipe or riser, so you don't have that geyser shooting up out of the ground yet, but you've still lost the pressure from that broken pipe that just hasn't surfaced yet, or you haven't noticed yet. It could be one of your shutoff valves is partially closed. Somebody brushed by it and accidentally partially shut off the water supply at that backflow preventer. That's going to burn off that pressure and your sprinkler heads don't pop up. Could be all or most of those wiper seals are leaking, so make sure that when those sprinkler heads are up and popped up, all the water comes out of the nozzle. It's not weeping out around that wiper seal at that pop-up stem. Could be a rock or debris was lodged in the pipe at the time of installation and has now moved or migrated to a point where it's actually causing a restriction. That's the last thing I would look for, because that's going to be the hardest one to find. That requires some digging. One of the biggest problems we see with these pop-up sprinkler heads, though, is they're running at way too high of a pressure. Most of these sprinkler heads want to operate at 30 pounds of pressure. You may have 80 pounds of pressure in your neighborhood, and the pressure loss that's normal going through the system may only be 20 pounds of pressure. So when you turn on these sprinklers, what you want to do is there's all sorts of fancy gauges you can buy to test the operating pressure of your sprinkler. Don't bother, you don't need it. You're just going to turn on the sprinklers when the sun is lower in the sky, and make sure the sprinklers are between you and the sun. And if you've got a high pressure misting issue, you're going to see that mist drifting away on you. So there's a couple ways you can deal with it. You can install a pressure regulator at the valve, just like you do with your drip irrigation systems, or you can install sprinkler heads with built-in pressure regulators. All of the manufacturers, quality manufacturers, do make models that have that built-in pressure regulator. Now that sprinkler head will run you about $7 instead of $4, but because now all the water coming out of that sprinkler nozzle is landing on the grass instead of blowing away, now you reduce your runtime a lot because you're not overcoming that loss. Okay, well, let me give one more thing here. Let me stop sharing. One of the manufacturers was kind enough. They molded one of their sprinkler heads out of plastic that does have that pressure regulator built into that pop-up stem. This is the most effective way to do it. Now every sprinkler nozzle is at that perfect 30 pounds of pressure. They cost more, but that's because they're worth it. Oops. Let me, slow motion. User error. Don't worry, it's me, not the computer. Okay. So clogged nozzles, you're just going to remove the old one and put on the new one. And actually, I didn't realize that was my next slide. So let me show you on almost every sprinkler head you have out there. Let me find one. I'm going to use the cheap one because it's easier to pull up. All you got to do is pull this guy up. And on almost every sprinkler head, you just remove the nozzle. There should be a little screen in there to protect it. Don't let this slip down into the head. Otherwise, you've got to turn the zone back on and actually get that to pop up so you can grab a hold of it. So you're going to put your new nozzle on. Now, these nozzles come in different patterns, whether it's a quarter circle, a third of a circle, or a half a circle. Some of them are actually adjustable so you can adjust anywhere. And those are ones that people usually buy. So that way I only have to buy one nozzle. Unfortunately, they're slightly less efficient as far as how evenly they apply the water. So if you need a half pattern, buy a half pattern and make sure it's pointed in the right direction. You can also buy them to throw different distances. 8 foot, 10 foot, 12 foot, and 15 foot are the common distances for those. If you do need to make minor adjustments to how far the water is going, that's what that little screw is there. The more you tighten that down, the more it restricts the opening, the less distance the water goes from the head. Now there is a sprinkler head out there, unfortunately, where you cannot replace the nozzle. So this comes with a built-in adjustable arc nozzle, and I know it's kind of hard to see in my lighting here. Oh, there's the opening. But by twisting this top, I'm just opening and closing that slit where the water comes out. If this one needs a nozzle replacement, you're replacing the entire head. This is made by Hunter. They do make a good head where you can actually replace that nozzle. So let's go back to share here. Here we go. Okay, got just a couple things to talk about bubblers because bubblers are very, very easy. Why aren't my bubblers bubbling? I promise we're going to be done in about 2 minutes here. I do apologize for this being longer than we thought it would. Really, bubblers are simple. You're going to replace any clogged bubblers by simply unscrewing it from the riser. Actually turn the system on to flush out any debris that may be inside there and put the new one on. That's all there is to it. For pipe repairs, we're not going to talk about doing any copper pipe repairs here today, but we can talk a little bit about PVC pipe. So you want to make your cut straight because you want that pipe to go all the way into the fitting. It is slightly tapered. Clean off any burrs that are left from cutting the pipe. And actually, really what you want to do is buy an inexpensive ratcheting PVC cutting tool rather than using a hacksaw. It doesn't leave any of those burrs behind. You want to make sure the pipe is dry. There is a glue out there that says you don't need to use primer. I prefer to use the primer, which cleans the pipe and pre-softens it. The glue is doing what's called a solvent weld. It is literally melting the pipe and the new fitting together. So the pipe is going to begin that process by pre-softening that plastic. Apply a thin, even coat of the glue to the pipe. More glue is not better. Remember, the glue melts the plastic. So big giant gobs of glue are not a good thing because it'll skin over on the inside and over the course of time just eat its way right through that pipe and blow apart again. Do a quick swab inside the fitting and put them together. If it's not fully connected on both ends, giving it a nice quarter to half turn twist to make sure that glue is evenly all the way around there. And you're going to hold it in place until the glue sets, which is about 3 to 5 seconds. The fitting is tapered, so if you don't hold it until it sets, the pipe will back out of the fitting just a little bit. Now, it will set very quickly, but depending on temperature and size of the pipe, it may be up to 10 hours before it fully cures. As a landscape contractor, any small dimension pipe, after I did a pipe repair, I would repressurize it right away and hope like heck that it didn't blow apart on me. You have the advantage of doing your own pipe repairs at home. Let it sit overnight to fully cure before you turn that water back on. Okay, so definitely flush out your system after that pipe repair. So what I'm going to do real quick is I'm going to drop out of here and stop sharing. So I'm going to show you what that ratcheting PVC cutter looks like. So we're going to open it up and we're going to put it inside our pipe. And one of the nice things about it, and you'll see each time it goes down a click, it cuts a little further through the pipe. The nice thing is that it automatically lines up and makes a nice straight cut. So what I'm going to do is to glue this into this fitting is I'm going to do my primer on the pipe, swab it inside the fitting, working very quickly when you get to the glue, thin, even layer of glue all the way around, swab it inside the pipe, push it all the way in. If you can, give it a twist, hold it 3 to 5 seconds. Now think about this. If you're doing a repair like this, a pipe that's already in the ground, and I want to make sure it goes all the way in, how big of a trench do I have to dig before I can lift up the pipe and bring it back down together? A nice fitting to use for that is what's called a compression coupling. This is an oversized barrel for the pipe it's made to repair. The threads screw off here and it's got a big rubber grommet inside there. So what you're going to do is on one end of your pipe, you're going to slide your cap on there and your grommet, and you're going to glue your two pieces of pipe together so they're only about that far apart. Make sure you get this part already on there before you do this. Every irrigator has made that mistake where we've got the two pipes glued together and we're still holding this in our hand. All right, well, let's cut it apart again and start over. But what we're going to do is we're going to kind of line it up to where that gap is in the middle of this. And when we tighten this down with our wrenches, that's going to make a good waterproof seal. Now we don't have to worry about bending that pipe up there. Another handy way to deal with this is there's a telescopic repair fitting out there. So I'm going to glue it into my regular fitting here. And my other piece of pipe I'm going to cut to be exactly the right length so that when I extend this, it will meet up. You do want to make sure this is fully extended so that O-ring in there does make it seal. If it's only partially extended, this is going to leak right there. So make sure it's fully extended. Okay. So a couple last things with your PVC cement there. Let me go back into share video. Oh, I think I cut that out. I think we're now back to the point where we say other options for help. You do have your irrigation supply stores, Ewing, Horizon, Site One, Sprinkler World. They have branches open in pretty much every city in the valley, and some of your larger cities have multiple branches, so your search engine of choice will find them. Another thing you can do is go to your irrigation manufacturer's tech support lines and websites. Rainbird's pretty easy to find at rainbird.com. Hunter's a little bit more challenging with hunterindustries.com. And Toro is easy. Irritrol is irritrolsystems.com. Now, if you have a product that is labeled hardy, these you're actually going to use Irritrol. They just changed the name of the company. It's the same company, but it is the same name of the company. So like I said, we can't teach you everything there is to know about this. And I really thought I was going to get this down to no longer than about 50 minutes. So I do apologize for the excess length. But I promise you I am finally done. For the one next week, I'm going to make sure I modify that a little bit better so we keep it to the right time. Thank you all for sticking with me, and I'll pass this back over to Dina now.
Well, thank you, Jeff. The presentation was amazing, even though maybe a little long. And we want to also thank everyone for attending our workshop today. As you can see on the screen right now, you have the communication information for both the town of Green Creek and the city of Chandler. And we just want you to know that when you close out of the WebEx today, you'll receive a short survey about tonight's class. Both Chandler and Queen Creek would truly appreciate it if you could take a minute to complete it for us, so we can use that information to improve our classes in the future. Thank you again, and I hope everyone has a great rest of your week.